This is Star Talk. Neil deGrasse Tyson here, your personal astrophysicist. And today, it's a Cosmic Queries edition on climate change and what NASA has to say about it and what NASA might be doing about it. And we've got here Chuck Nice. Chuck.
Hey, Neil.
You know, you think a lot about climate change. I've seen you do some philanthropic activities in this place.
I devote a lot of my time to trying to educate people through entertainment and other means about the climate crisis.
Okay.
I call it that because it is.
Because sometimes you got to make them laugh to have them listen, I guess. Is that?
Yeah. That's how I've stayed married all these years.
Okay.
Yeah.
So while whatever you know and I know about climate is not the level of expertise we require to have a show based on that subject. And
Right.
So we combed the landscape and we said, oh yeah, the recently appointed NASA chief scientist is also the NASA's senior climate advisor. What do you think of that? What? And we've got her on Star Talk now. Katherine Calvin. Kate, welcome to Star Talk.
Thanks, and thanks for having me. I'm really excited to be here.
So if my notes are correct here, you've been an Earth scientist at the Pacific Northwest National Laboratories Joint Global Change Research Institute. Did I say all that right?
You did. It's a lot of words, but yes. And I've been there. I was there from 2008 until the beginning of this year.
Okay. I don't know if anyone told you, but it's got Pacific Northwest in it, but it's based in College Park, Maryland. Did someone make a mistake there? Did I?
And by the way, they need a longer title too.
Oh, for sure. There definitely could be some more words in there. No, it is. So the Pacific Northwest National Lab is headquartered in Washington State, but they have a small group based out of Maryland on University of Maryland's campus.
Oh, gotcha. That's where you were. Okay. Yeah. So that's a good explanation for this. Okay. But your research focused on climate change, but especially where the human civilization influence it and is impacted by it. Is that a fair characterization of your professional profile?
That's correct. I was looking at how human activities cause climate change and what climate change does to human activities.
That's quite a do loop there. Okay.
It's a nice little feedback loop you got going.
I know. All right. So remind us all what just NASA chief scientist does. Because NASA has a lot of scientists, but to be chief scientist, what does that mean?
So my job as chief scientist is to integrate science across NASA to represent that science externally, including with other agencies, international partners, the public, people like you. And I also provide advice to the administrator on science.
Administrator is the head person at NASA. The head person of NASA.
Oh,
Yeah,
okay.
The administrator. Yeah. Right. Okay. Right. And so now, is this the first time that chief scientist has been a climate scientist? Because I've known many a chief scientist, and all the ones I've known have been astrophysicists or planetary scientists. Is this the first time?
No, there was an Earth scientist whose research was on the cryosphere a while ago. So I'm not the first climate-related person in this role.
I only just learned the meaning of the word cryosphere. That's the badass word. Chuck, do you remember what it means?
It means everything frozen
anywhere
about anything
at any time,
including iced tea, ice cube, vanilla ice.
Vanilla ice. They're in the cryosphere.
It's all in the cryosphere.
Yeah, I love that word. I love it. So this is a Cosmic Queries edition, and we've collected questions from our most loyal fan base, our Patreon members. And Chuck, you got them. You got all the questions.
Got them right here on the trusty tablet.
Let's do it.
So we might as well. Let's jump right into this with Mason. Mason says...
Mason didn't even give you his last name because he didn't want you to try to pronounce it.
I think his last name is Jar. So
Mason Jar. Okay.
God, what a dad joke that was.
That was so...
God, that was so...
That's right.
Like, yeah.
But you are a dad, so that's legit. It's legit if you actually are a dad.
If you are a dad, right?
Right,
yeah.
right, okay.
I actually heard my children just go, man, stop. Stop it, bro. Okay, here we go. What are NASA's plans to combat climate change? Are there any long-term, short-term plans in regards to the rising levels of greenhouse gas emissions? I've read interesting things on huge towers filled with moss plants that could help filter the air. Is this something NASA may be helping with?
Wow.
Look at that.
Yeah. So I think so, Kate, isn't this on the scale of geoengineering? I mean, it's a whole other concept there. So other than give us data about what we're doing bad and possibly advising on what we should be doing, what is in the power of NASA to actually fix this?
Yeah, that's a great question. So NASA, first of all, we observe the Earth from space. So we can provide data that helps inform decisions about climate change. And we've been doing this for decades. So we have a long array of data about things like vegetation or carbon dioxide or temperature to see how Earth is changing. In terms of how to reduce and to mitigate climate change, NASA has two roles in this. One is we do climate modeling, so we can understand what the effects are of different emission scenarios in the future. The second is we actually develop technologies that can help mitigate and adapt to climate change. So we have a sustainable aviation program that has been working on reducing fuel use and emissions from airplanes.
Making them more efficient in all ways, I guess,
in all
aerodynamically
ways, yeah.
as well as their engines. And I just got to interject there. Correct me if I'm wrong, Kate, but your climate group in NASA is based in New York City. Is that correct?
The climate modeling group is based in New York City at the Goddard Institute for Space Studies.
Yeah. Goddard Institute for Space Studies. And they are over the restaurant that's featured in Seinfeld.
That's
the
right.
building that houses that restaurant contains the Goddard Institute. Am I correct about that, Kate?
Yes, you are.
All right.
What's the deal with climate? Who are these people?
So this is encouraging. But how about these concepts of like moss towers or carbon dioxide scrubbers out of the atmosphere? Is this still science fiction?
Well, I think when you talk about removing carbon from the atmosphere, there are a number of different techniques in there. The most common one would be planting a tree. And so planting...
What a concept!
We've been doing it for a while.
Why didn't I think of that?
Society. But yeah, trees take carbon out of the atmosphere, and that is one way of reducing carbon. I think NASA's role in this is really on observation. So we can actually look at the trees and measure how many trees we have, how they change over time. We also measure carbon dioxide, so we can monitor how that changes over time.
So a biological question, since you brought up trees, is a tree the most effective plant that can remove carbon? Is there something that we could be planting in addition to or other than trees that would actually pull out more carbon?
Good question.
It's a good question. It's a complex question because it depends on the type of tree, where you're planting it, what was there before. And so the effect of a planting of a tree on carbon depends on a lot of factors. Trees also change the way the Earth's surface reflects energy. So where you plant those could also have an effect, not just from their carbon removal.
So isn't it true that it's not good enough to only think about the carbon dioxide in our atmosphere, because the ocean has something to say about this, doesn't it?
Yeah, that's important. So the ocean absorbs quite a bit of carbon. So when we emit carbon into some of it goes into the ocean, some goes into the land, and some stays in the atmosphere. Oceans also uptake heat. And so they play a really important role in climate change, both today and how that changes in the future. And so the more we can understand the oceans, the more we understand climate.
But if I pull CO2 by whatever magic way out of the air, the ocean says, oh, wait, I can give you more CO2. Isn't that right?
Well, there is a balance in that. So when you you move carbon from one pool to the others will respond until they reach an equilibrium.
Okay.
Oh,
yeah.
Wow.
Okay.
Look at that.
So you can take it out of the air, and the ocean said, here's some more.
Right.
You ain't getting away that easily. You put it in here to begin with. I'm just giving it back to you. I think that's that dialogue, right? Right. All right. So Chuck, what else you got?
All right. Let's move on to Sarah Perry. And Sarah Perry says this: hello, Star Talk. Climate change has been a huge discussion for a while now, and I keep hearing scientists and politicians say that we're approaching a point of no return. I don't know why I said that like William Shatner. I don't know. a point of no return. Anyway, we need to act now, is what they say. My question is, what exactly is the point of no return? Are we actually close to the point of no return? And what is close anyways? What is the tipping point for a major climate change? And how much time would that tipping point take to completely change our atmosphere and our weather? So,
yeah, what's up with tipping points, Kate?
I'm detecting a very distinct skepticism in Sarah Perry's question.
No, I get a total apocalyptic state of concern there. I read that differently. It's like, is it a tipping point? Are we there yet? When is it going to happen? What can I do about it? It was because it has a kind of manic flavor to the rapid sequence of questions.
I see that.
All right. What you got, Kate?
Well, I think what's important to know is that we're already experiencing the effects of climate change now. So the planet has warmed, and along with that, we're seeing heat extremes. We're seeing increases in wildfire. We're seeing changes in our in precipitation and in water cycles. And what the science shows is that as warming continues, those will increase. So we will see more changes in temperature, more heat extremes, an increase in the proportion of intense tropical cyclones, more wildfire weather, and so we'll see more and more of that as temperatures rise.
So you're not thinking of it as a tipping point as much as we're just entering the gates of hell and systematically but I think the tipping point implied that no matter what we do, we'll never reverse it.
Right, and there are some parts of climate that are irreversible. So things like ice sheet melt and sea level rise. Once an ice sheet melts, it's irreversible on the timescales that we're typically talking about. So it could take centuries to millennia. There are other impacts, though, like the heat extremes that are reversible. If you can bring global mean temperature back down, you would reduce the heat extreme again. But it depends on the impact, whether it's reversible or not.
I hadn't thought about that. There's a difference there, because if you melt ice, you're not remaking that ice because we're not in an ice age, right?
Exactly.
So you raise the water level, that you're stuck with that. But everything else, maybe we can get a handle on. Okay.
What if we got 10 million battery-operated refrigerators with ice makers?
That would work, Chuck. I'm sure. Yes. Okay.
I would need to do some more math on those numbers.
Yeah, do math on that, Chuck, before you bring that to the table. And it just pumps out the ice cube out the back.
It just keeps shooting out ice cubes.
They did it in the Beijing Olympics. Those mountains didn't have any snow on it. They said, let's bring in some snow and some snow makers. So, all right. All
right. Well, Sarah, there you go.
But Chuck, you got to remember, there's no free ride in the world of thermodynamics. Right. So you needed energy to make the ice that your refrigerator was punching out the back door.
Right. So even battery operated or solar powered.
Solar would work.
Okay.
I think solar. So, yeah.
So
you'd put them where there's very little sun, which is in the polar regions. You're not kidding.
There you have it. Yeah.
I keep working on that, Chuck.
Here's what you're saying.
What?
Think this through, Chuck. Go ahead.
I think it needs some research. Yeah.
Do a little more research on it.
Right. Yeah. Make that your dissertation, Chuck.
So, Chuck, let's see if we can squeeze one more in before we take our first break.
All right. Here we go. Hello, Neil. What is keeping nuclear energy from being the mainstream when it's clearly a better scalable option than most of renewable energies that we are currently using?
Nukes. Very cool. All right. We're going to pick that up after the break. What role do nukes play in our future of climate change? How about that? Okay. And you'll be ready for that one when we come back, Kate?
Not a direct answer, but an answer.
Okay. Okay. We'll have an answer for you from Kate from NASA when Star Talk returns. We're back on Star Talk, Cosmic Queries. We're talking about climate change and NASA with NASA's chief scientist, Katherine Calvin. Katherine, great to have you. In your academic pedigree, what did you do your PhD on?
My PhD is in a department called Management Science and Engineering, but it was really applied math. So I learned how to develop mathematical models to do things like optimization and understand how to write a computer program using math to describe a system.
So this is something I think we don't have enough of in this world today, because everyone, you go through the stovepipe field. I'm the expert in this one thing, and somebody else is an expert in some other thing, and no one brings it all together when the whole world actually operates systemically, right? So we need more of you out there.
Well, and that was a lot of my last job. So I view math and computer science as sort of a universal language. If you can write an equation, you can write a computer program, then you can then link it to any other kind of science. And that was part of what I was doing, was linking physics with ecology and economics and hydrology.
Yeah, it's not enough of that, for sure. Yeah. So Chuck, we last left off. Who asked this question?
So this is Tiago Pereira from Portugal.
Portuguese. Welcome. Yes. Yeah. Okay. And that question was about nuclear power as an alternative source of energy to fossil fuels,
right?
Possibly being our savior. So Kate, as a scientist, but also as a public servant, how do you weigh what the science tells you and what people want, if what they want has a deep emotional resistance to a solution?
Well, so I can say is in my role as chief scientist and senior climate advisor, and similar to my role before, my job is to provide the science to inform that. And so the second part of that would be on the purview of someone else. But what science can tell you is what the effects are of a particular option you might be considering on a variety of different factors. So how does it affect emissions? How does it affect something else? And a lot of what the science I was doing before was looking at was what if scenarios. So what if you do more of this or less of that? And what does that mean?
And you model all this. You get to model that.
Exactly. Right. And we just provide science-based information that others can use to make decisions.
But if people are spooked by Chernobyl, they're spooked by Fukushima, and old timers.
The Hulk.
Radiation.
Yeah.
Yeah. If they have some sort of they're spooked by that from decades past. If we know, for example, that modern power plants are not susceptible to those problems, what do? Do you try to say, look, folks, warm up to this because that might be our only solution? Or do you just take a step back from that, let the politicians worry about it, and still just pump the science into the dialogue?
Well, I think for me, with my background, I'm not a nuclear engineer or a nuclear expert. And so in this, I can only say what the kind of research I was doing was, which was we would include it as a portfolio of options and see what happens in different what-if scenarios. But I view the role of a scientist is to provide an unbiased characterization of any technology, regardless of what it is. So this is what we know about it, and try to provide as much complete information as we can, and very precise information. So this is how it affects this, or this is how it affects that.
So that makes way too much sense. That you're just making too much sense here.
Yeah,
exactly. Remember, this America we're talking about.
I was saying, yeah. Who needs that? Who needs your measured response about what works and data, empirical evidence? How do I feel about this, Kate?
That's all that matters.
Right.
It's how do I tweet about it?
First of all, Kate, here's what I want to know. What about the children? No. All right, let me ask for real. Do any of your models actually give us kind of...
Are you asking this question, or is it a Patreon question?
No. This is a follow-up that Tiago actually had.
You a lion? No. Okay, go on. Go on.
Do any of your models have a percentage mixture of what energy sources are best?
Not best. So again, science can give you information. Best is a qualitative word, right?
Okay, say optimal. Optimal.
So what we can do is sort of look at what if you wanted to do, limit warming to a particular level. What if you wanted to do this, and look at what worlds might be consistent with that.
I got you.
Very good.
So when you say what if, you're talking about if you want this outcome, this much carbon must be, reduced. And these are the ways that you could do it. Is that what you're saying?
Right. So what some of the reports on this that are really thorough are from the Intergovernmental Panel on Climate Change. And so that's where I would go if I was looking up something new in climate. And what they've looked at is if future warming depends on future emissions, and they can look at, how much can you emit of carbon dioxide and stay within a particular warming level. And then they provide some example pathways that are consistent with that. And those pathways would show you, what sorts of emissions reductions would you need to do in order to get to a particular level. But it's very much what if. If you want to limit warming to a particular level, what is consistent with that, and what can the science tell you about that?
That just makes so much sense.
It does.
I mean, we need more of this kind of thinking in government, for sure.
In other words, we're doomed.
In case the only one talking this way,
right? Exactly. We need more rational, evidence-based thinking. Oh, brother.
All right, Chuck, what else you got?
All right, here we go. This is Jonathan Brown. Jonathan says, hello, Dr. Calvin. Hello, Dr. Neil. And hello. Okay, never mind. I'm not. It was like, yeah, hello, Chuck. Yeah. Okay, really? Fine. Okay. Could you please discuss natural climate change that may take place over thousands of years on Earth and how humanity directly accelerates or alters this process? I think one of the main arguments for climate change skeptics is that they think it's solely a natural process or cycle that has occurred and will continue to occur over time on Earth. And maybe that's true, or maybe it's not.
Just before you reply, Kate, I will not elevate their comments to the level of skepticism. It's a level of ignorance. Okay. Don't confuse skepticism with abject ignorance. Okay. Right. Of how things work. Okay. Kate, take it.
So there are natural changes in climate. Some of them are very long term. Some of them are short, like El Nino, La Nina. But what we see in the last 150 years is an unprecedented rate of change. And when the scientists have looked into what's causing that, it's attributable to greenhouse gas emissions. So the increase in greenhouse gas emissions since the late 1800s has led to this change in climate. And we can see this through a number of different ways. We have laboratory studies that show that increases in concentrations of greenhouse gases trap heat. We can learn from other planets about what happens when you have more greenhouse gas emissions in the atmosphere. We can also learn from models about what happens there. But what we see in the last 150 years is unprecedented, and the science has attributed it to human activity.
So I heard something interesting, Kate, that if there is a silver lining, what we're doing now to the climate will delay the next ice age.
Let me just say.
We are going.
Alex, I'll take what the hell for 500.
The spirit of Alex. Okay.
Exactly.
I mean, temperatures are going up now rather than down, but I think what's challenging is that the rate of change that's happening. So we're experiencing these impacts, and we're experiencing them at a very quick pace compared to natural climate cycles. And that makes it harder for ecosystems and people to adapt.
Mm-hmm, mm-hmm.
Okay.
Well, I can tell you, if we do enter another ice age, whenever that is, the water evaporates from the oceans and it snows onto the land, and then it just stays there because it never melts. And you'll systematically drain the water levels of the world, creating new oceanfront real estate all around.
Well, you sound like a super villain right now.
Lex Luthor, my next plan. So, Chuck, next question.
All right, here we go. All right, Jeff Johnson. Jeff Johnson wants to know this.
Are you picking names that are easy to read?
Of course I am.
Okay.
Yeah, lie about your name or just give me some initials, people. No.
Go.
No, Jeff Johnson actually did write in, and he said, hey, there's a lot of talk about terraforming Venus or Mars. But I am curious, what are we doing, if anything, to terraform our own planet? Does this fall under the realm of climate change initiatives? Quite a lot of our planet is desert or other harsh land types. Should we consider terraforming these places on our own planet?
Well, if I can add to that question, Kate.
Sure.
Do deserts serve any role in the world? Do they like, I don't think much of anything lives there. All right. If we terraformed our desert, wouldn't that be beneficial to everybody, to humans as well as creatures and vegetation?
So I think all parts of the Earth system play an important role in the world that we're living in now. And anything that you change, you need to carefully consider what the effects might be. And that's one of the things that we do in climate science, is try to understand these effects. There's a lot of concern around desertification and land degradation, so that as you change, as precipitation cycles change, as you impact the Earth, it affects the terrestrial system. There's also, deforestation or afforestation that changes the Earth's surface and how much vegetation that you have and what the world looks like.
So afforestation means you had a forest over here, but now it's over there?
Adding trees. So adding new trees in
adding
there.
trees. Okay.
Yeah.
Okay.
And you could simultaneously deforest and afforest in theory, but we look at it as they're separate processes. One, you have fewer trees, one, you have more. But essentially, as scientists, what we look at is what would the effects of each of those things be, either using models or laboratory experiments. And then at NASA, we observe that from space so we can see how those things change over time.
So with respect to that and Jeff's question, they're wiping out forests in the Amazon. Is there any data that lets you know what that's going to do to the planet? And are there any models that say, if we continue, here's what's going to happen?
Good.
Sure. So changing tree cover in general affects carbon. So trees store carbon, and if you cut them down, you change the amount of carbon that the Earth can absorb. You also, if you burn them, you release carbon into the atmosphere. And so you're changing the amount of carbon dioxide, which we know carbon dioxide leads to warming. The other thing that happens is you change the reflectivity of the Earth's surface. So trees, and you can change water cycles. So in high latitudes, so in the Arctic, if you cut down a tree and then there's snow instead, you're changing how much energy the Earth reflects. In low latitudes, you change water. And so changing trees can affect temperature both through changes in carbon and through other factors and have an effect on local warming. And we do study this. We measure it and monitor it. We do modeling based on this to try to understand what's going on now and what might happen in the future.
Okay, it sounds like you have like 100,000 million variables, right? From the reflectivity to the water cycles to the oceans to the land to the rate that you're making it, the rate that it's pulling back. How isn't this just some beast, this multi-headed beast in your computer? That how do you tame it? How do you have any control over that at all in any kind of way that leaves you confident in what results come out? And plus, it's a term you haven't used, but I'm thinking you're dancing around it, and it's unintended consequences, right? There's like, if you do this, like you said, Chuck, if you cut down the forest, well, we've modeled these 7 things. Is there an 8th thing you hadn't thought about that could change where the locusts land or something? And then the scientists end up getting the bad rap. Scientists neglected to consider. Meanwhile, we predicted everything else right. So how do you tame the beast?
So first of all, there's thousands of scientists doing this. So it's not one person, and they all approach the problem from different disciplines, so they can think about different things. And then we break it down in models. We were writing mathematical equations and computer programs, and we can isolate parts of that and make sure we get that part right before we link it to the next part. And this is where observations like the ones that NASA collects is really important, both to initialize your model, to help parameterize your model, and to evaluate the model. And so the models I was working on before use data like what we get from satellites to help develop them and evaluate them.
Okay, I neglected to fully consider that. So however beastly the program is and all the factors that it's considering, people look to NASA and say, wait a minute, NASA has a data point that says this is not as variable as we thought. That puts a constraint on that, and I have a limit on that, on this other variable. And so this helps localize what the damage the beast can do, it sounds like.
Exactly. So all the observations that we collect help constrain the models and help us develop them going forward. And so we can break apart those pieces and get confidence in each of them.
Very cool.
Wow. So, okay.
All right, Chuck, one more question. Maybe we can slip it in before we take our second and final break.
Okay. Michael Boisvert. Michael Boisvert
Okay.
You know what? I'm going to call him Michael Boo.
Okay. That's
All right, Michael Boo.
Okay.
He
All right.
says, hello, Dr. Tyson, Dr. Calvin, Lord Nice. We figure out how to solve the human problem. Could we slow down the melting of land ice while we figure this out, can we slow down the melting of land ice by 1, sprinkling something on it to raise its melting point? A quick search of terabutylene ammonium hydroxide raises it to 86 degrees Fahrenheit. All right. Also sounds like you gave the Earth cancer. And then lowering its thermal conductivity by scooping it up in a machine that would expand it like an aerogel. Oh, this is, Boisvert. That's how you say his name. Boisvert. It's Michael Boisvert. He gave me the phonetic spelling at the end.
Not a good that did.
Thanks.
So, Kate, this is again sounds like it's from the category of geoengineering, and these are ideas that maybe work on paper, but do you get to put in your models these sort of crazy future geoengineering ideas to try to help that out?
I never specifically studied geoengineering, but there are people that do, and they try to understand them. And a lot of the ones that people talk about are stratospheric aerosol injection, so reflecting the sunlight by putting aerosols high up in the atmosphere.
Cloud.
And you can look.
High clouds, yeah.
High clouds.
Uh-huh.
But what, as a scientist, what we're trying to do is understand what that might mean. And so what you see in some of that, you can reduce temperatures from doing something like stratospheric aerosol injection, but there's a lot of uncertainties and a lot of risks and a lot of things we don't know. And one thing in particular to think about is that doesn't do anything. If you're doing something like that, you're not reducing carbon dioxide. So something like ocean acidification isn't going to be impacted by that.
Interesting.
All right, we got one segment left. We're going to take a break, and when we come back, we might go into lightning round. What do you think of that? See, we get more of these questions out of, because we just luxuriate on these answers with all these questions. We have so many interested parties there. So, Chuck, why don't you do a quick filter for this break, and when we come back, more with Dr. Katherine Calvin from NASA on Star Talk. We're back, Star Talk, third and final segment. And it's a Cosmic Queries, and we're talking about climate change and NASA. And we've got the chief scientist of NASA, Dr. Katherine Calvin. And Kevin, is there a best website for people to track NASA's climate activities?
NASA has a climate website and includes a set of indicators for NASA climate, including things like what temperature rises today compared to before, current CO2 levels. They have a lot of indicators.
That's a geeky.
Yeah,
that's the kind of stuff geeks love.
Yeah,
geeks love it.
Oh yeah.
Okay, what is that handle?
I think it's climate.nasa.gov.
Okay.
There you go.
If not, just Google climate and NASA, and you'll probably find
I got
it.
a feeling it's going to come up.
It's going to come up. All right, Chuck, give me some more questions.
All right.
And let's see if we can do like a lightning round. We'll put Kate on the spot, pretend like she can only answer in sound bites, and see how many questions we can get through here. Okay.
All right.
This
Give it to me. Teresa Anoski. Teresa says, hello, Dr. Tyson. Hello, Dr. Calvin. Lord Nice. What a huge volcanic eruption, throwing an ungodly amount of particulate into the upper atmosphere, caused a temporary cooling on the Earth as it has in the past. For instance, Krakatoa. Thank you. Thank you.
Yeah.
Yeah, so volcanoes do inject sulfur into the atmosphere, and in previous really large volcanoes, we see it in the temperature record, but it depends on the amount of material coming out of the volcano and how high it goes, what the effects are on climate.
Yeah, because we forget, we just think of the atmosphere as one monolithic thing, but if in your head it's layers, right? In your studies, and so particles at different layers have different effects, is what you're saying, right?
Yeah, I think a good example of this would be something like ozone. So in the stratosphere, ozone protects against incoming UV. And on the surface, ozone causes local health effects.
Right.
Right.
Yeah,
So I
nobody's
got a
thinking about it.
feeling that the stuff coming out of a volcano might also have some local health effects.
Yeah. You mean risk of vaporization?
Yeah, I'm
Shortly
just
after
saying.
eruption.
Just saying, maybe
Just
that
saying.
might be a bit of a problem.
Just
All right,
saying.
very cool.
Wait, Chuck,
Very
you don't
cool.
remember the Krakatoa movie? Krakatoa East of Java? It was one of the disaster movies from like the 1970s.
I do not know that movie.
Yeah, Krakatoa East of Java. And the problem was Krakatoa is actually west of Java. So I don't know why they named the movie that way. I checked it on a map when I was a kid.
That's where they ran.
Which way they ran. All right, keep it coming.
All right, this is Achilles Kashyap, who says, hello, Dr. Tyson, Dr. Calvin, can you tell us more about how NISAR, N-I-S-A-R, is different from other Earth-observing satellites? Also, will it be able to contribute to climate science?
So, Kate, what's different about that satellite versus others?
Well, it's really looking at how the surface moves and dynamics that are happening on the Earth's surface, like ice sheets dynamics and landslides.
Okay. All right. Because that matters, right? Of course.
It does.
That would matter. All right. All right. Cool. And do you remember what it stands for? NISAR? That's always a test.
Yeah.
You can just make something up. We'll be good with that.
I don't remember the exact acronym.
Okay. All right. We won't hold it against you. Nobody ever remembers acronyms. So, all right, Chuck, keep it coming.
All right. Abhinav Yadav, who says,
I know he doesn't pronounce it that way, but go on.
I'm sure he doesn't either, to be honest. Like, I'm looking at it, and it's just Yadav, but it's probably pronounced like Johnson. I don't know.
it's
because
like Yadav.
Yeah,
Just say
Yadav.
it. Get a little Slavic flavor in there. Okay. Go.
Abhinav Yadav, who says, wow, you know what? You did make it sound better. I got to
I know. I'm telling you.
Hello, Dr. Tyson. Hello, Dr. Calvin. First of all, congrats to you, Dr. Calvin. And secondly, what options do we have now to deal with climate change, given the most recent report states smaller efforts will have no impact? Uh-oh.
So, Kate, this is right up your alley where humans are interacting with the climate, climate's interacting with humans. Is there some threshold below which we're not doing a damn thing?
I'm not exactly sure what we're asking, but what I can say is that what we can look at is how different levels of emissions or emissions reductions or emissions increases affect temperature, and sketch that out. I think one thing that's really important to know is that there's other processes like El Nino, La Nino, and so you might not see, temperature isn't smooth going forward. It hasn't been smooth in the past, and so there are levels where you might not notice temperature change in the same way because of natural variability.
Okay, but in terms of actions that I can take, paper or plastic, electric, or there's little decisions I might make in a day.
Tesla or Hummer?
Okay.
Airplane or hang glider?
I think people just want to know, is what they're doing having any effect at all? I think that's, at some point, that's what people are asking.
And it's a great question. I think what science can tell you is what the different options might mean. And there are people that track emissions over time. So, we can look at how things have changed in the past. And there are people that study what the effect of individual technologies or actions might be on emissions in the future.
Okay.
Well, let me just, if I may, Doctor, because I know the report he's talking about. And it speaks to the inefficacy of individual action creating enough of a significant change. But I will say that what individual action does do is it causes people to become engaged in the issue itself.
Other forces end up operating.
Exactly.
A collective forces, right.
A collective force. So it doesn't make a difference if whether or not you recycle actually makes a difference. The fact that you're recycling actually brings the issue to the fore, and that may cause you to take other actions as well.
Yeah, okay. It's a behavioral shift. Right,
Exactly.
Right.
Yeah.
And so, Catherine, our crack team of researchers looked up the acronym, and oh my gosh, okay, this acronym contains 2 letters that are themselves the first letter of 2 other acronyms. Okay,
Awesome.
So this is we got nested acronyms. Okay, I got it here, right? So NISAR is NASA, itself an acronym. ISRO. So it's just the I from the I. NASA ISRO synthetic aperture radar.
Yep. So the 2 agencies that are leading the mission plus the technology.
Look at that.
All
Very
right.
cool.
That's acronyms gone wild.
It really is.
All right,
All
keep
right.
it going. See how many more we can get in. We got 5 minutes left. Go for it.
All right, here we go. This is Dylan, and I like Dylan. He's got one name, like Cher. Dylan says, "Hello, Dr. Tyson. Hello, Dr. Calvin. The great comedic co-host. What? Finally, somebody actually is complimentary. Okay. As someone who has to grow up with this troubling issue, I was wondering what the future would be like if by some magic all fossil fuels were stopped burning now and we went to 100% renewable energy today. Thank you all for what you do." Interesting.
Oh, that's
Any
gonna be
models
something
on
in your
that?
model. You could probably model that.
Yeah.
So it stops today, and then what happens next?
Yeah, so there was actually a study on this that was in the last couple of years of looking at what if you halted fossil fuel emissions today. And what you get is that essentially climate will stay at the level it's at today. And so what we know, though, is that we're already experiencing climate impacts. So we would keep those levels of impacts. And what the science really says is that future warming depends on future emissions. So more emissions in the future, more warming. Stopping emissions, you keep your current
So if we
warming.
stop today, we don't reverse what has happened. We just don't get worse.
Right. To reverse climate change, you would need to take carbon out of the atmosphere.
Rather than stop putting it in the atmosphere.
Exactly.
Okay, that's an important distinction. And very tightly answered there. That's damn near a soundbite for you.
Yeah.
Okay. All right.
All right, here we go.
Keep it
Neil.
coming. All right.
Hello, Neil. Hello, Chuck. Hello, Catherine. Violetta here, your 13-and-a-half-year-old astrophysics kid writing from Washington, D.C. with this question.
This is the Violetta.
This is the Violetta.
Give her full name just so we get the full thrust here.
Okay. Violetta and Mom Izzy. That's the full name.
That's the full Something about those 2 names. Violetta and Izzy.
Violetta. Izzy.
Sorry, Mom.
Yeah,
but
you're right.
Your daughter's got a way cooler name than you do. Okay.
Oh, man, I never thought of it that way. Violetta and Izzy. Okay. Here we go. She says to Dr. Calvin, what is your absolute #1 goal in your role as NASA chief scientist, and how do you plan to achieve it? Thank you for being a role model to young women everywhere.
Oh. Ooh,
Wow.
cool. Okay.
Yeah, so I just think NASA does amazing science. I've been involved with some of the climate work before, using it in the work I was doing. We also have all of this really cool astrophysics and heliophysics and planetary science. And I just want to make sure everyone knows what NASA's doing throughout the entire portfolio.
Wow.
Okay. So because that would, you can't govern in clouds of ignorance. So NASA feeds information and data to those who have the power to do something about it with laws or legislation and the like. Is that a fair characterization?
NASA provides information that can help decision makers at all levels make informed decisions.
So do they call you in front of Congress, or do they call the administrator in front of Congress?
I don't know the answer to that.
Okay, I think they should call you in front of Congress.
Yeah, exactly.
I vote for that right now.
All right, here's the follow-up question from Violetta. She's asking, because of her age, how does one get appointed to be NASA chief scientist anyway? It sounds like the coolest job ever. I'm just saying, you might find yourself passing the torch to me one day. She's out for your job.
She's getting
look at
OG on us. Oh my God.
Snap.
Oh man, a couple of years ago it was, I'm Violetta and I have a simple little question.
Right.
Now she want to take over the world.
Exactly. Now she's just like, I'm taking down the chief scientist of NASA.
And there's nothing you can do about it.
Yeah, I will say I agree with her. It's the coolest job ever. I get to learn science every day. I get to talk to people about science, and there's nothing more fun than sort of seeing what energizes a scientist and then trying to capture that energy and explain it to someone else. In terms of how you get here, just keep asking questions and keep learning.
Yeah, and so it's not like you lobbied for that post. You were just very visible in your work, and NASA goes around and says, there's somebody we could use like right now in this seat. I mean, isn't that basically how that happens?
Yeah, so I think that there was a multi-stage interview process, but they were looking for someone that knew climate science and that could help elevate NASA's climate science, as well as represent the rest of NASA science.
And do you have to be approved by Congress, by the Senate?
No.
Okay, so you're an appointee by the head of the agency. I'm
serving in an Intergovernmental Personnel Act mobility program.
Ooh.
Okay. I don't know what the hell that is.
Okay. No, I think it's like they built a set of highways and freeways so they can move expertise simply and easily without what would normally be the red tape, however red tapey that title sounds.
It's a way of doing temporary assignment between the federal government and other eligible entities.
Yeah.
Very cool.
And it allows the federal government to tap expertise that it might not otherwise have access to within its own circles.
Exactly.
Right.
Wow. For a very bureaucratic sounding name, it's relatively efficient.
Yes. It's a badass way to get talent where you need it when you have to have it. Dr. Calvin, it's been a delight to have you on Star Talk. And I hope this is not the last time we get you on. I know the Intergovernmental Panel on Climate Change comes out with these intermittent reports, and maybe we can reach back into your office and get you back on Star Talk. But our fan base was delighted by this, so thank you for this.
Yeah, thank you for having me, and I'd be happy to talk to you guys again.
All right, Chuck, always good to have you, man.
Always a pleasure.
All right, this is Neil deGrasse Tyson concluding yet another episode of Cosmic Queries, Climate Change Edition. As always, I bid you to keep looking up.